Hello friends and welcome again. And I have updated my tool uh, with few more options, but I will again explain all the components here. So we can use this tool to generate PEB buildings with different type of buildings like clear span, multi-span 1, multi-span 2, multi-span 3, then 4, multi-cable 1, multi-cable 2, monoslope and multi-cable with monoslope. And in all these options, I have given a user input span spacing, so we can change the spans uh, multi-span one also, and automatically the heights will adjust accordingly. Now let us take an example of multi-span 4. So this tool will be helpful to generate the 3D models very quickly within 2 to 3 minutes, and all stat file will be ready in use with all the loadings and everything, all the design parameters, all the loadings, all the load combinations, crane load combinations, everything automatically. Don't need to do anything. Now let us take one example. Let the building length will be 100 meters and width, let us suppose 95 meters, and let us take height of 10 meters, slope 10 meters. Let us say expandable again along first grid line. We have more two options. So let us suppose only one first grid line is expandable, then 3D frames, and let the outer column support be fixed and inner should be pinned. In test file we can give anything. I'm not changing the width of the spans right now, but it will be, you can change anyone, like automatically it will change. Now base spacing, this was already inputted. So we want 100 meters, but it is showing 99.549. So we have to adjust this. So one base spacing of 1,500, one base spacing of 8,500, and another 14 base of 6 meters. So total 100 meters. Now if you want to model end wall columns, we have to click the option, and then if you want to release this end wall columns at the top, then we have to click this. Now total there are 5 spans. So in end wall also we have to specify how much distance we want to keep the end wall columns. So let us for first span, the first column will be at 7, and second let us say at 14, and third will be at 21. So we don't need to specify 21, automatically it will take. So here same 41, 14. This is like 7.5. Let us suppose this is 6, 12, 7, 14. Uh, you can provide different end wall column spacing. Let us try for this example different. Let's try for 7, 14, here 6 and 14. 6 and 15. Now accessories, head guards. So generally I prefer, if at the brick wall I prefer one guard, and at eve we will have one gut automatically, and if you want all the guts to be modeled, then you need to specify the spacing. Let us suppose at every 1.5 meter you want space guts in left wall, then you can provide that. But generally I prefer only gut at brick wall location and at the eve location, so I will give the spacing above the building, so it won't generate. Now sometimes there is a tie runner at the crane location, so you can also give the spacing at 6 meters or something, so that it will automatically generate a tie at that location. We can trick like this. Now for the purlins, we have two options, but it will connect the end walls only, and secondly it will connect the it will model at every particular distance. So if you want a fixed purlin spacing, then we can take 1.5, and if you want to connect the end walls, we have to just make sure that option is ticked. So I generally prefer to connect end wall columns only. Let us suppose we have to release this. Now bracings. So bracings location, we have to provide the bracing location, and it also shows that it should not be exceeding 16 because we have total 16 number of bays. Okay, so for roof, left wall, right wall, you can click yes or no if you want it, and then you can also specify portal height. Let us suppose 4.5 meters. I want a portal height for left wall side, and right wall side I want the bracing till bottom. Now member tension to the bracing members, so it will provide the member tension to the bracing members. If you want to yes, yes or no. Now canopy. So canopy, there are 20 different options, and you can select, and in one single option you can give number of canopies. Like in right wall, if I want canopy orientation downwards at height of, let us suppose, 6 meters, width of 3 meters, and if I want bracing, yes, I can try it. Now in left wall, I can select upwards 6 meters, 3 meters, bracing if I don't want, no. Then let us suppose 3, 4, 5. Continuous I want in 3 B spaces. Now in front end wall, let us suppose straight at 6 meters, then 3 meters, bracing let us suppose no. Suppose 5, 6, then 10, 12. So 5, 6, 10, 12. Now roof monitor, there are 17 grid lines. So 16 number of bays and 17 grid lines. So from grid line reference 2 to 16 I want. Let us suppose height I want is 1.2 meters and width let us suppose 2.5 meters. Okay. Now fascia. So fascia we can give on all the four faces. Let us suppose all faces are on fascia. And fascia height will be 4 meters and width we can give 0 also and any width also. Let us suppose 0.5 width. Okay. Now for the mezzanine. Mezzanine is two orientation, x and z direction. So whichever orientation we select, it will put the main members in that orientation, and this joist in second orientation. So let us suppose in x direction. Now this offset is when we are joining our mezzanine to the existing frame. So this is our existing frame. Now I want a mezzanine, like for example in this way. So I want the mezzanine to be joined to this column. So I have to provide a x distance, x offset distance. Now let us suppose I want the mezzanine in this corner. So what I will do is I also want to join at the end wall. So the end wall spacing at first span is 7 and 14. So what I will give, the x offset is 7 meters. Now z offset will be the base spacing. So base spacing, first base spacing is 7.5 meters. Let us suppose 7.5 meters. Then x1 offset is if I am connecting to this column. So this column offset is 21 meters and last column is 14. So 7 is the offset. So I'll give x1 offset as 7 and z1 offset. So I don't want to extend my mezzanine till whole length of the building. So I have to restrict till some distance only. If I'm extending to whole length and if the mezzanine is touching at this end also, then I have to give Z1, otherwise Z1 will be 0. Let us suppose the height is 5 meters and joist spacing is 1.5 meters. Now X column location, where I want the column. I want columns at 7 meters and 14 meters because the end wall spacing is 7 and 14. So I have put 7 and 14. You can give any location, but let us suppose that mezzanine is joined at that end wall location. Now in Z direction, we have to give the base spacing. The first base spacing is 7.5 meters. Second base spacing is 8.5 meters. So this will be 7.5 plus 8.5, that is 16 meters. And third is 6 meters, so 22. Let us suppose we want only 3 bays of mezzanine. Now take another example. Let us suppose the mezzanine orientation in Z direction and the mezzanine is in the center. So we want mezzanine at this bay and location will be touching this wall. Now same x offset. So let us go again in this 15-meter span. So 15-meter we have only one column 7.5. So x offset will be 7.5. Now z offset. So z offset is 0 because we don't want to take our measurement to that whole level. So 0. Now x1 offset is again the base width and minus the column width. So 15 minus 7.5, that is 7.5. And now Z1 offset. So Z1 offset is the last base spacing. Let us suppose 6 meters. It is already given 6 meters. 14 base at 6 meters. Last is 6 meters. Now height I wanted 5 meters, 1.5 meters. And now X location. So X location will be, so it is, we want column at the center. So 21 plus 20, that is 41, plus 7.5. So that will be 48.5. So there is, we only want one column at the center attaching to this column and this column. So X column location will be only one. Now in Z, again we want three spacing. Then what we can do is, first will be, so 100 minus 6, that is 94, then 88, then 82. So 82, 88, 94. Because all 14 members are 6 meters. So mezzanine 82, 88, and 94. This location we want column. Now we will generate the loads. So in loads, there is dead load, collateral load, live load. We can specify in kilonewton per square meter. You can take a category. Now mezzanine dead we have 4.75, let us suppose, and then mezzanine live, let us suppose 3 kilonewtons. So mezzanine dead and live. Now column loads, we can give as many as column 15 column loads. Like option is uh, pipe loads or any other loads. So pipe loads, total load is 5 kilonewton, and you can give as moment also kilonewton, and distance from the grid line, let us suppose 7 meters. In category, dead load or imposed load, and you can have all columns, left side columns, right side columns, interior column 1, interior column 2, all interior columns, or this. Let us suppose left side columns only. Okay. Now crane loads. So in crane loads, let us suppose bracket width is 600 meters, and there is crane system 1, 2, 3, 4, 5, and I have given the numbers Vmax and Vminimum that we have to calculate by modeling the crane beam or surge beam model. And let us suppose I have given all the cranes the same, and then bracket height we have to give. Since this bracket height we have given above the building, it is showing load is not okay. So let us suppose at 7 meters. We can give different bracket heights. Now in wind load, if you see, we have to give only wind speed, parent category, design life, and this factors. You can change it, anything from the drop down. Same for the seismic and design. We can use LSD design and WSD design for IS 800 and AISC design. So we can take the member strength, yield strength of hot roll sections, and these all things, and purlin spacing for LXLY, purlin gut spacing for LXLY calculation. So let us suppose 1.5, and we want to design purlin instead. Then if you want to design instead, yes. If you don't want to do, no. Then member sizes. We can add member sizes. Generally for outer columns, knee rafters, and this all we will take tapered column. We can choose any of the sections. So let us suppose we are doing with taper eye. So for taper eye, I have already specified some sections. You can change it. Now let us suppose for roof monitor I beam, we can take 300. Then for fascia, let us suppose 154. Bracings generally you can give anything. Round bar also Tata SHS. Pipe tube. Let us suppose angle of 75, 6. And Z purlin guts also you can give channel, pipe, tube. Let us suppose Z purlin in canopy. Let us suppose I beam of assembly 100. Canopy bracings 16 diagram. Mezzanine I have given some sections. Now just to click to generate the model and specify where you want to save the file. File will be generated. This is running in the Excel. You can close the program. Now in the test file. Also, it will automatically generate the uh, comments inside Staad input. You see, whole model is ready with two of the mezzanine perfectly. One side canopy is above, the side is below, and I think in this side it is straight. Okay. Bracings in second way, then this way, and last way. And if you see the input editor file, it will also show the comments. Member properties, seismic force, member releases, then calculation of the dead load, live load, column loads if we are using, then wind pressure calculation. So everything is fully automatic. All the design parameters, takeoff also it will take steel takeoff, mainframe and wall columns. So everything is online done. You see mainframes and wall columns, bracings, fascia, I'm sorry, roof monitor, fascia, purlins and guards, canopy, and mezzanine. So everything is distinguished. All the loads if you see, the frame loads, then mezzanine dead load, live load of frames, mezzanine live load, wind loads. Automatically wind loads in fascia is also applied in end walls, in roof monitors. Everything is applied as per IS standard. In canopies also, crane loads, all the crane bracket heights are also different as per the span. Everything is automatic. Now, after modeling, there are some things we need to do. That is, first of all, we need to remove the duplicate nodes and 0.1, enter. We have to merge it and always select delete the second nodes in all sides. So it will delete the second nodes and it won't change anything. All the loads, all these are perfectly intact. Now, second thing is you have to select the bracings, then inverse selection without selection any bracing, and then we have to go for a tools, geometry, and intersect selected members, intersect, and we have to give 0.1. So whenever we are generating the crane brackets and bracings and purlins, it is going to generate some duplicate nodes and some this. But we have to just create these two options. Now it has split the whole structure wherever there were nodes. Again, check for duplicate nodes 0.1. There are no duplicate nodes. Check for duplicate members. There are no duplicate members. Check for zero let member 0.1. There are no zero let members. And check for multiple structure, single structure. Everything is okay. So only two things, we have to remove the duplicate nodes and we have to intersect the members. These two things and everything is okay. If you see mainframe, still the same, hand walls, bracings, monitor, fascia, purlins and threads, NOP and mezzanine. So everything is intact, and if you see the nodes also, they will also be automatically split. This is the frame loads and live loads. Since it's a big file, it is taking time to save, and all the win loads, if you see, everything is okay. Now directly run the analysis. All the member properties are given, and since we have given the member properties, or if the members are split also, it will all automatically take uh, the splitting. Since they are tapered and they are split, so it will automatically take the split. Okay. So directly you can give the analysis. Nothing we have to do. Thank you.